Good morning, Pon. I'm Suzy Sin, and my matrix number is 01DDT20F1118. Today, I'll be presenting the problem-based task with my partner, Lim Kai Sin, and the topic we've chosen for our PBT is Smart Home System. So, the first slide is about introduction of Smart Home System. A smart home refers to a convenient home setup where appliances and devices can be automatically controlled remotely from anywhere with an internet connection using a mobile or other network device. Devices in a smart home are interconnected through the internet, allowing the user to control functions such as security access to the home, temperature, and lighting remotely. And the next slide is table of contents, which is divided into Part A and Part B. Part A includes problem statement, objective, scope, project significance, and literature review. And I, Suzy Sin, will be in charge of discussing these 5 topics. And my partner, Lim Kai Sin, will be in charge of discussing about these 5 topics, including cost planning, TinkerCAD design, explanation of IoT system, demonstration, and conclusion. So the first topic is problem statement. And the next slide is problem statement. By looking at this graph, it displays the revenues generated by waste electricity generation worldwide from 2011 to 2020. In 2020, electricity generation from waste generated $3.22 billion in revenue. In order to solve this crisis, smart home system has been promoted more than ever. Home automation is popular nowadays because it provides ease, security, and efficiency. It refers to control the home appliances by using computer technology. So, we're planning to design a home automation system that is capable of learning and executing daily routines at an economical cost. And the next topic is objective. The first objective of us decided to build a smart home system is to ensure more efficient use of energy. For example, users can have more precise control over the heating and cooling of their home with a programmed temperature sensor that learns the schedule and temperature preferences and then suggests the best energy efficient settings throughout the day. Lights can turn on and off automatically when users enter or leave the room, so users never have to worry about wasting energy. The second objective is to enhance resident safety and security. For example, home automation systems can connect automated door locks and other tangible security measures throughout the home. Users can also choose to receive security alerts on various devices when alert goes off and monitor activities in real time whether they are in the house or halfway around the globe. And the last objective is to improve the quality of life and convenience in the home. Being able to keep all the technology in the home connected through one interface is a massive step forward for technology and home management. Theoretically, all users have to do is learn how to use one app on their smartphone and tablet, and be able to tap into countless functions and devices throughout their home. This cuts way back on the learning curve for new users, making it easier to assess the functionality of their home. And the third topic is scope. So this scope refers to 2 different scopes, which are user scope and system scope. User scope means by targeted user, including residents, family, and house owners, while system scope refers to smart home system scope, which are smart door lock, lighting control system, and air conditioner. And the fourth topic is project significance. The first project significance, or we call benefits, of the smart home system we built is keep the home safe with smart door locks. Replace the current front door lock with a smart door lock to lock and unlock it using password or controlling app remotely. By using smart door lock, users are able to check and make sure if the door is locked after they left, enhancing the home safety and security. Secondly, manage home temperature and save energy by using a temperature sensor. A temperature sensor is able to measure the temperature of its environment and give signals when temperature changes by turning on and off the air conditioner. Besides, users are also able to manually and remotely turn on and off the air conditioner to adjust home temperatures through an app. And lastly, control home lighting with a photoresistor and a PRI sensor. Both sensors allow users to control the lighting in every room of their house based on the motion and brightness of the day. This ensures the efficient use of energy, and users will have no worries about forgetting to turn off the lights after they left their house anymore. The fifth topic is literature review. The first smart home system that is highly recommended is Amazon Alexa. With more than hundreds of millions of compatible devices, Alexa is undoubtedly one of the most comprehensive smart home ecosystems available today. It makes every aspect of your smart home easy to access and control. Since Amazon's ecosystem is one of the most prevalent in the industry, most smart products integrate seamlessly with Alexa, including products made by Philips, Samsung, Nest, and Scalage. Alexa can now close your garage, lock your doors, and adjust your home's temperature. The second example of smart home system is Google Assistant. If there's any true runner-up to Alexa, it's Google Assistant. Even though Google Assistant has less third-party integrations, it can often answer questions and complete commands Alexa can. Thanks to Google's major ownership of the search engine space, Google Assistant has an accuracy score of 92.9%, which means it has a great understanding on how people naturally speak. Below are the other smart home devices that are under Google's production. And the third example is Wing Hub. Wing Hub is touted as the first smart home hub designed for the mainstream consumer. Unlike Alexa or Assistants, Wing doesn't have any brand loyalty, allowing users to pick and choose different smart product brands and merge them seamlessly with one another. And the last example is Samsung SmartThings Hub. Samsung System unites a wide variety of smart devices from different brands including smart thermostats, Wi-Fi router, light bulbs, and security devices. Users with the smart system get a SmartThings Hub wall mount and can get full access to the smart devices connected to the hub through the SmartThings iOS or Android app. And that's all from me. Now I'll pass the presentation to my partner, Mkaisi.
Good evening to our lecturer. My name is Kaisi, and my matrix number is 01-20F1002. So now I'm going to continue this demonstration by the sixth one is cost planning. So I list out the components that we need to use in this IoT system, which is buzzer, keypad, motor driver, DC motor for prototype only, battery, resistor, breadboard, Arduino, jumper wire, PIR sensor, temperature sensor, photoresistor, metal box, light bulb base, and also light bulb. And this is a list of components that we need to use in this IoT system. So I estimate the cost of the hardware is 140 ringgit. And next is for the Blink software. Blink software is that we might need to use in order to manipulate and receive the data from the IoT system. And the cost is shown in the picture at the right here. So next is 7, TinkerCAD design. So this is the circuit that we designed for this IoT system, which is only the basic idea only. We use this motor as the simulation to act as a role of aircon. This is bulb, this is photoresistor. This is temperature sensor, buzzer, keypad, Arduino, PIR sensor, and battery. So this is the coding for declaration for the icon variable, light variable, door lock variable, and this part of code is for door lock, and same to this, and this is for buzzer, and this string password is the right password. We declare a right password in this coding, and this string BS top is for receive the input from user. So this is the setup coding, which is we use for the to declare the variable, which is input or output, and we also identify the initial state. This is for motor, we put it low, which is stop the motor, and this is for lightning, and this is for door lock. And this is the method for light control. As you can see on the first line of here, we read the audio status, the photoresistor sensor to which is the light sensor, and this is the PIR status. We read the PIR data, which is used for detect the motion, and we print out the LDR status, and if the LDR status, the value of the LDR is lower than 200, then the lights will on, which means the environment is dark, then we need to on the light. So else we off the light. Next. So this is icon control, icon method. So as you can see, we read the temperature sensor, and then we convert the output to a readable Celsius, and then we print out the data. So if the temperature is higher than 35, the icon will on. So if the value is lower than 35, the icon will off. So next is the main method, which is the loop function, and the basic flow is we get the input from user, and then we substitute the number with the asterisk symbol, and then we store the input. So next we will check the condition. If the password is right, we will turn on the buzzer, and then we will call the light method and the echo method. So if the password is wrong, we will turn on the buzzer to indicate the password is wrong, and then we clear the input, and then we ask the user to input the password again, which this program will go back to this line of code. So this is the flowchart of this IoT system. Basically, it is first we going to input the password, and if the password is wrong, it will ask the user to input again the password until the password is right, and then the system will check the LDR status and PI status, which is the brightness of the environment and the motion detection. So if both this is true, then it will on the light. After you on the light, it should go to the check temperature. Correction here again, there must be an error from on the light to the check temperature. So if one of these condition is false or both are false, then it will go to off the light, and then it will go to check the temperature. So a little bit of correction here again. If the temperature is less than 35, you should off the aircon, or if the condition is false, it should on the aircon, and then next the program will end. So next is 8, explanation of IoT system. So this is the definition of IoT system. The IoT basically means describe the network of physical objects, things that are embedded with sensors, software, and other technologies for the purpose of connecting and exchanging data with other devices and systems over the internet. So IoT system that is a device that embedded with network and sensors. The sensors will first collecting the data, and the data will be sent to the cloud. The cloud is act like a middleman between the device and the user to make the communication between the two parties possible. So some kind of software or algorithm will start to process the data, then the result will be sent to the user. So for example, let's say we have the IoT system that equipped with temperature sensor, and the device will continuously collect the data by using sensor. Then the result of the sensor will be sent to the cloud, and the data will soon be processed until the data is readable, and then the final result will be delivered to the user interface. So next, I'm going to demonstrate the TinkerCAD. As you can see in this interface, this is TinkerCAD interface. At the left side here is the circuit that we designed, and the right side here is the coding that we write. So next I'm gonna to demonstrate and start this simulation. So I open the serial monitor, and then the system asks us to enter the passcode, and then now I'm going to type the wrong passcode. Then as you can see, the buzzer will on, and the coding will look back to the first here and get the input from the user again. So now I'm going to enter the right password, which is 1234, and the buzzer will on, but the different sound compared to the when we enter the wrong passcode. So now we enter the system, we can observe that the LDR status is low, which means the brightness of the environment is low. The light will turn on when somebody is going by near the light. So PIR sensor will add as a role to detect the motion. So if the motion is detected, the light will on. So if the environment is bright, then the light will not on. So it also depends on if somebody is near the light or not. So next we're gonna see this temperature sensor. As you can see, the temperature of the current temperature of the environment is 25 Celsius. So if the temperature is high, the motor will turn on, which means the aircon will turn on. So in this case, we use motor as only as a simulation. So if the temperature is lower than 35, maybe I go take 31 Celsius, then the aircon will turn off because the temperature is lower than 35. So the final is 10, conclusion. So in brief, in this problem-based task, we designed a home automation system that could control the lighting by depends on the brightness of the environment, and control the air conditioner by depends on the temperature, and also the door lock system with keypad. So objective of this system is basically improve the quality of life and convenience in the home, and enhance regional safety and security, and ensure more efficient use of energy, reducing electricity bill and economical costs. And the system we design is capable of learning and executing daily routines at an economical cost. And that's all from us. Thank you.